Hello everybody and welcome back! In this new episode of Drops, we will talk about the ability to float in the water that fish possess. How are they able to stay still in the water without moving a fin, and of course without sinking? Let's go to find out, but not until you have subscribed to our YouTube channel. Don't miss the subscribe button and the bell. Take a look at our TP page as well. If you like our videos and want to give your contribution to our projects, this is the right place. You can make a single or a monthly donation. It will be extremely helpful to carry on with our series. Okay, now it's time to explore the underwater world. Many bony fish possess a particular organ called swim bladder. It consists of two sacs filled with air, used by fish to control their buoyancy without expending energy in swimming to maintain a certain depth. The swim bladder is positioned in the dorsal portion of the fish, above the digestive tract. It derives from an extra flexion of the esophagus. The walls of this organ are flexible, permitting its expansion or its contraction. In addition, they are poured in blood vessels and are lined with granin, which make them impermeable to gas. A complex of blood capillaries, the rete marble, is connected to the swim bladder and helps fill it with oxygen, additionally playing an important role in the regulation of body temperature. Well, let's see how this particular organ works. First of all, we need to make a distinction between fish with the swim bladder directly connected with the alimentary canal through a pneumatic duct called Physostomous fish, and fish with no connection between them, called physoclistous fish. In the first case, the swim bladder works as a lung. The air enters the mouth of the fish, passes through the pneumatic duct and fills the organ, allowing the fish to adjust the quantity of air inside the swim bladder and consequently controlling the buoyancy. If the organ is filled with air, the fish will go up, and vice versa, by emptying it, it will sink. It is the same principle that makes us buoyant while scuba diving. Inhaling and exhaling, we can control our position in the water column. You can experience the same feeling in the sea without any underwater equipment. On the surface, try to breathe out without moving. You'll notice that you start to sink. Your lungs are emptying, and they can no longer keep you on the surface. After this experimental digression, let's analyze the second case. Without a pneumatic duct, fish need other specialized structures to fill the swim bladder with air. We are talking about the gas gland and the oval. The first one introduces gas to the bladder in a peculiar way. It secretes lactic acid and produces carbon dioxide, causing acidity and a consequent loss of oxygen from the hemoglobin. Then the lost oxygen diffuses into the swim bladder thanks to the rete marble. On the other hand, the oval allows the reverse movement, letting the oxygen diffuse back out again. Besides controlling fish buoyancy, the swim bladder is also involved in respiration, perception of pressure fluctuations, and function as a resonating chamber to produce and receive sounds. When sound waves propagating through the water hit a fish, they make its body vibrate, and the gas inside the swim bladder amplifies these vibrations. Moreover, some fish can produce sounds with their swim bladder during courtship, or can confuse predators making squeaky sounds. Having a swim bladder, however, isn't always a positive thing. In fact, fish can contract an illness called swim bladder disorder. This discomfort mainly concerns aquarium fish, especially goldfish. It consists of a malfunction of the organ, usually due to gastrointestinal problems. The cause? Fish voracity. When they eat too much or too fast, their stomach is filled with air. But there are other concurring reasons that lead to this disorder. Parasites, stress, bacterial infection, dirty water, wrong temperature. When it happens, the fish can float on the surface upside down or sink to the bottom of the aquarium. The swim bladder can also rupture. When a fish gets caught and is hauled upwards to the water column, it can't decrease the quantity of air quickly enough. The swim bladder expands, causing fatal injuries to other organs, and sometimes leading to its rupture. The fish will no longer be able to swim. and there will be nothing to do. Unfortunately, the fish will die very painfully. We are coming to the conclusion of the video, but there is one last additional specification to consider. Did you know that some fish don't have a swim bladder at all? Exactly, cartilaginous fish, such as sharks and rays, lack this organ. You must be wondering how they can control their buoyancy. Well, some of them manage it simply by swimming, because they possess negative buoyancy and would sink if they stopped. Others instead take advantage of the fat and oils stored in their liver. Of course, having a cartilaginous skeleton, much lighter than a bony one, plays an important role in the regulation of their buoyancy. Thanks for watching. If you have any questions, write them in the comment section, as well as suggestions or appreciation. Take a look at our link in the description to help us improve the quality of our videos. And naturally, remember to subscribe to our YouTube channel. See you next week!